Alright, so welcome back to your favorite inorganic tutor YouTube channel. Today is another episode. We want to learn how to find the mode, alright, given the PDF, right? So now this is the question on the board. The PDF of a continuous random variable x is given by this function, right? This is the piecewise function given. It's a continuous PDF, right? And we are asked to find the mode, right? And we all know that to find the mode of a continuous random variable, which is x, right, with the given probability density function, right, with this particular probability density function 2x e power minus s squared, right, on the range, 0 is less than or equal to x, less than infinity, right? We need to first find the value of x that maximizes the PDF or that maximizes the probability density function, right? So first we have to take the derivative of this probability density function, right, with respect to x, right? And then we set it to 0 to find the critical point, right? So now let's find the derivative of this particular function given, right? So the derivative of this particular function, which is the 2x e power minus x squared, is going to be the derivative, the first derivative of the function, right? This is a product function. So we are going to use the product rule and then the chain rule combined, right? Because we have two functions combined here. So now, what the product rule also says is that when two functions are combined, you first differentiate the first function and then you maintain the second function plus differential of the second function, then maintain the first function, right? So now let's go. Using the product and the chain rule, we have differential of this function. We have 2 e power minus x squared plus 2 power e minus x squared plus 2x, right? 2x into minus 2x e power minus s squared, right? Because when you differentiated the exponent, it's going to minus 2x. And the first part, when you differentiated the x, we have 1. And that is what we have here. So we have first derivative is equal to 2 e power minus s squared minus 4x squared e power minus s squared, right? So from here, let's simplify the derivative, right? So from here, we can see that f of x, right, the first derivative of x will be equal to 2 in 2 power, we have e power minus x squared common here. So we have 2 e power minus s squared into 1 minus 2s squared, right? Because e power minus s squared is common, we have factored that particular number out, right? So we have 1 minus 2s squared inside. Here, we can now go ahead and say that since we have been able to differentiate the function, the PDF, we have to set it to 0 to find the critical point, right? So setting the first derivative to 0, we have 2 e power minus s squared into 1 minus 2s squared equals 0, right? So here we have this, the inside to be equal to 0, right? So we have 1 minus 2s squared should be equal to 0, right? So we have 1 should be equal to 2s squared, right? So we divide through by 2, and we have s squared is equal to half. But we need x, so we take square root on both sides. And when we take the square root, we're going to have plus or minus root of 1 over 2. And that is equal to s equal to plus or minus 1 over square root of 2, right? So this point, we have s value to be 2. x1 is equal to plus 1 over square root of 2, or s equal to minus 1 over square root of 2, right? Since this power minus s squared cannot be equal to 0 for any real number, we can say that the only critical points, the only critical numbers are plus or minus 1 over root of 2, right? Now, let's proceed. Let's proceed. So now we can conclude and say that since s is defined for this range, 0 is less than or equal to x less than infinity, we have to assume, or we have to discard the negative aspect of the variable, right? So we are going to discard the minus 1 over square root of 2, right? So therefore, we can say that the s value is equal to 1 over square root of 2, right? So this becomes the mode of the random variable of the PDF, right? Because of the range given, we cannot consider the negative aspects of the variable, right? So we take the positive 1 over square root of 2, and that becomes the mode of the continuous random variable x, right? So that is it. It's very simple. When you are given the PDF, the continuous case, and you want to find the mode of that continuous PDF, you just have to first find the derivative. You have to make sure that you maximize the function. So you find the first derivative. After that, you set it to 0. So when you set it to 0, you find the critical numbers or the critical point. So when you get the critical point, then consider the range that was given. So here you see the range is 0 less than or equal to x less than infinity. So right, so we cannot consider the negative number. So we considered 1 over square root of 2, and that becomes our final answer for the function given. Thank you very much for watching. Proceed, and don't forget to subscribe, because I'm going to produce with more content on probability, calculus. My next content is going to be how to find the inverse of a particular function. Keep watching.